Hello? You hear me? Yeah. Welcome to this talk. My name is Ole. I work for Knowit Experience Bergen. And today I will try to introduce you to the JAMstack. How many of you have heard of the JAMstack before? Okay, so not that many people. How many of you have actually tried it? One person. Awesome, that's great. I was afraid that like everybody knew what it was all about, and I would give you nothing new. So that's good. What we're going to talk about today first is just what is the JAMstack? What does JAM stand for? Then we do a comparison with a more traditional architecture. I've used a lamp because of the lamp stack, not necessarily the lamp stack, just a lamp is easy to illustrate. Then we look at the how. How do we build a JAMstack? How do we set it up? We look at the tools that we can use to build this site. We'll then take a look at the workflow, both for the developers and the editors that are going to put content on your site. Then hopefully we have time for 1 or 2 demos. And then we do a quick recap. Yeah. So let's start at the beginning. So JAM stands for JavaScript, APIs, and markup. So initially, when I heard this, I just thought this is just a fancy way of saying that you are building a single-page application. It's just a SPA, right? Because that's what a single-page application is. It's JavaScript, APIs, and some markup. But that's not it. It's actually, unlike other stacks, JAM doesn't refer to specific technologies. It's more about the architecture and how it's actually built up. So as you can see, like JavaScript obviously is a language or a technology-specific thing, but it's like any framework, React, Vue, Svelte, whatever you like to use. Yeah. So like what is it? How does it look compared to a normal stack? So let's take a look at the traditional approach. So traditionally, your user has some browser and they want to reach your website. So they start out by requesting this page from whatever domain you have and ask the CDN, yo, can I have the site that I'm looking for? The CDN, if it hasn't cached the site, then says, sure, I just need to check with the load balancer. The load balancer then takes a look at the request and tries to find the correct web server. So when it has done that, it has the web server for the correct site. The web server then has to find the template that it's going to use. And most probably you have some data that you need to pull from some data source, like a database. So it's actually one more step where you go ask the database for your data. Right? So now we've gone through the whole thing, and then we have to go back. So the database tells the web server, hey, here's your data. The web server then compiles the template on the fly. Says to the load balancer, here's your site. The load balancer then tells the CDN, I have the site. And the CDN answers the user. So this happens every time you ask for a website that's not cached, right? So how does the JAMstack does this? Well, you start with a browser. It then makes a request to the CDN. And the CDN returns the site immediately, always, to the browser. So you always have the site readily available on the CDN, ready to go without any compilation or on-the-fly transpilation of the template. So how does it do that? How is that possible? How can you have dynamic websites that updates their content dynamically from like a CMS? And it's never going further than the CDN. So let's take a look at the how. So the whole gist of the JAMstack is that if you publish any content, be it code, be it a new article, be it a new configuration option, a new label on your button, this will trigger an automated build in your build system. So you have some kind of build system set up where you can post to a webhook, which will then trigger a build and deploy your code base. right? But now, instead of only doing that when you release new code, you do it when you release any content. So the difference is that instead of getting your data during runtime, when the user asks for it, you just pull all the data during build time. So if you publish your content to, say, Contentful, which is this headless CMS, you pull data from that CMS when you run the build. So that means any changes you've made is obviously saved to that system, and you then retrieve it during build time. So initially, I thought this couldn't work. Like, this takes way too much time, right? You can't generate your entire page every time you do an edit. But it's surprisingly fast because it's only text files. You're not pulling down any binary files. Like, images are just references, right, to some URL, and PDFs, or like every binary asset obviously doesn't get pulled down and compiled into an HTML document. So you do this and you deploy it, and now suddenly you have the whole website served as a static site that's immediately available from the CDN right on the edge. So you can obviously also supplement it with APIs, like your own microservice APIs, for example, if you need any specific business logic. Or you could use like third-party services that have like domain-specific knowledge to the API that you want to use. So yeah, let's take a closer look at like how do you actually build this? What tools do you need to achieve it? So there's 3 main categories. That's first, you need a static site generator. So this is basically your engine, right? That's retrieves your data from some data source that you specify and spits out a finished static website. And then you will need some build tools and a CDN, obviously, to serve your content, build your content. And you would also need to pull the data from some kind of data source. So let's take a look at each one. So for static site generators, there are a lot of options lately. Like lately, it's been a big boom in how many alternatives you have. But it started out with Jekyll, which wasn't the first, but it was the first that like went kind of mainstream, because GitHub used it for their GitHub pages. So you probably use this feature where you can upload a specific folder to your repo, and GitHub will then generate a site for you that anyone can visit. So it's basically a free site host, a website host. So Jekyll kind of started this off, but then someone came along and created Gatsby, which took this a step further. So like Jekyll, it gets the data from some data source that you specify, but instead of using like HTML or some weird templating language, it just uses React. So now you suddenly unlock the full power of React in your static site really easily, and can serve the static, really fast website also with all the features that React provide, which is really cool. Also, GridSum came along. That's what I've used. That's exactly the same as Gatsby, but for Vue, if you like Vue better than React. And lately, there's been a lot of buzz around Eleventy, which is a generator written in JavaScript. And the reason this has become so big lately is that it's really easy to set up. Like, you don't need any configuration if you don't want it. And it also supports a lot of templating options. So like, you could use Mozilla's nunchucks, you could use Markdown files, you could use CSV files, you could use JSX, whatever. So that's a really good tool to use if you have a lot of different templating engines that you want to use, right? So there's this site called staticgen.com, which has a great curated list of good static site generators. And if you're at all interested in trying some of them out, this is a good place to start. So let's take a look at the properties of your build tools and your CDN. So you can obviously choose any build tool, any CDN, but there are some best practices that When you read about the JAMstack, most places says that these are like really crucial to make the site or the JAMstack work properly. So first, you want atomic deploys. This means that when you're deploying a new site, you don't want your site to start uploading, like it needs to upload 100 files. You don't want it to start uploading file 1 and then file 2 and then file 3, because then you have this weird partial state where you have some new content, some old content. You want everything to be deployed at once, right? So you want everything uploaded, finished, and then do the switch. So everyone gets the newest content everywhere. You obviously want automated builds, because that's the whole premise. You want it to be really easy to just start a new build on any changes. So this must be really well integrated into your build tools. Without it, this wouldn't really work. You also need to have a good cache invalidation. So obviously, since this lives on the CDN, you need to invalidate the cache on the CDN. So this must happen every time that you deploy a new website, so that all your users get the latest and greatest features of your website immediately. And lastly, version control is mentioned a lot, and the point they're trying to make is that in the JAMstack, it should work in a way where you could just do a git clone, some standard procedure like npm install, and it's ready to run. Like you shouldn't need to download an entire database, an SQL server, set up this other framework on your computer to make it run, right? It should be just like this own thing that's just a website. No backend to run. That should just be available somewhere. All the config files should live in the Git repository. And this means that it's really easy for new developers to come into the project and just start developing. No need to set up complex backends and other structure on your dev environment. So then you have the data sources. So I've listed 2 types of CMSs here that we're going to take a closer look at. So the first one is Headless CMS. How many of you have used this Headless CMS? One. So a Headless CMS, that's just, the word comes from the head being cut off from the body, right? So in a normal CMS, you have the body, which is the CMS itself, where you, like the back office, where editors edit things and where you add your code. And then you have the head, which is the public-facing part, like the website itself. So a headless CMS is basically just a CMS system that just have API access. So you access your content via API instead of the more traditional way. So that's what the headless CMS is. So here too, you have a lot of options. Like you have the contentful option, which is the most popular one. That's the CMS as a service. So that means that all your data lives on someone else's server. But if, like for small hobby projects, or if you're content with it being in the cloud on someone else's cloud, it's a really good service to try and use. They also have a really generous free plan if you just want to try it out. The same goes for Sanity, which is actually a Norwegian company, which is quite cool, and they like sponsor a lot of open source JAMstack projects lately. But it's the same thing as Contentful, really. Also, generous free plan if you want to try it out. But if you don't want your data to live on someone else's server, there's the Stroppy project, which is an open source project that you can run on your own computer or your own box, which is the same thing. It's a CMS system that provides a really intuitive and good API for every content. But you can also use Epi and Umbraco. Both of these actually provide a headless CMS now. So this approach can actually use on these 2 systems that at least is very popular in Bergen. So you could use it on a site that you're already running. Yeah. So the thing is, when you publish here, you not only publish it to the database as a normal CMS, you also trigger the build hook, so that you retrieve your content upon build time. So here's a good address to look at if you want to get a good list of all the headless CMS options out there. And the other kind of CMS is the Git-based one. So it's this really cool concept where every single thing, including your data, is supposed to live in your repository instead of on a database. So instead of saving your files to the database, these CMSs actually adds, commits, and pushes it to your repo, meaning that you have an version control of your entire site, like at every state, both content-wise and code-wise. So the most popular one probably is Netlify CMS, which is an open source project. And what it does, for example, if you wanted to create a draft, it just creates a branch, right? So it creates a branch called draft or whatever, and pushes the content to that branch. And that means that your build actually won't be triggered, so it won't be public-facing. Because your build obviously only triggers when you push to master. So when you want to publish, they use, I think they integrate with GitLab, Bitbucket, and GitHub now. So they just creates a PR, completes it, and pushes it to the server, and then you're good to go. Then this will start a new build. And thus you have complete history of every change in one single place in your Git repository. So you could also do this to assets, like where you would publish like images to your repository, but if you have any like non-trivial amount of assets, that would get really big really fast. So the way they've solved it here is that you can provide like a service like Cloudinary, where when you try to upload a picture, for example, to your CMS, it just uploads that to Cloudinary and you get the link back. So then you just have text files, which is really fast to process. Alternatives is just anything, any data source. FaunaDB, a great serverless database thing that works really well with this stack. Really easy to use. Also generous free quota if you want to try it out. You could just get it from any API, a public-facing API, your own API. If you're a developer and you have a blog, and you are comfortable writing your blog posts as markdown files, it could just be a folder on your repository called blog posts, and you just pull from that. So whenever you want to post a new blog post, you just push a new markdown file to that folder. Or JSON or CSV or an Excel file. Yeah, question.
From an editor perspective and user-friendly interface,
Yeah.
what of these do you recommend?
Definitely the headless CMSs. So both Contentful and Sanity is really customizable. It comes out of the box with a pretty UI, but it's also really customizable. So if your customer wants something specific, you can customize it and make it look like whatever you want. So this is probably the best for like non-developers to use. So let's go one step further. Yeah, so now let's take a look at how the workflow is. So there's two actors in this scenario. So you have the developer and you have the editors. So for the developer, the workflow is really similar to what you're used to. You make some changes to your code, you push it or hopefully make a PR into the master branch, and then this triggers an automated build in your build system, which then do an atomic deploy and invalidates the cache. And that's how like the build pipelines already work, right? So this is nothing new. But the thing is now it works the same for the editors, right? So editors go into their CMS and they click publish, and for them it seems like any normal CMS, right? There's nothing new here. But what happens in the background is that this triggers a build, right? So upon publishing, it's saved to whatever data source the CMS uses, and it triggers the build, which then picks up these changes and does an atomic deploy and invalidates the cache. So now the editor like flow looks really similar to the developer flow. Yeah. So let's try to do some demos. I first want to demo Foos Invite, which is a demo I made 2 nights ago, which is inspired by Phil Hawksworth, which is a developer at Netlify, like a CDN, really popular CDN for the Jamstack, where he created this virtual lolly that you could send to your friends, right? So I've recreated it just with a Foos person. So now we can send our friend a nice invite to play some foosball with us. So let's give him white shorts. I don't know, purple. And it should be really purple football. And let's invite our friend Bill Gates. Hi, Bill. Want to join some foos later? And this is from me. So, what's going to happen now when I click this button is that it's going to post this data. This is just a form. It's going to post that to an anonymous function, which takes that data, uploads it to FaunaDB, which I mentioned previously. And if that's successful, that save, it will trigger an automated build at Netlify, and thus giving us this invitation available for everyone to look at. So let's click it and see what happens. Hopefully it will work. Yes. So here's our link. So what's happening now over at Netlify, so if we go to deploys, you see that it started building and was deployed by our trigger. By our new invite hook. So now this should pick up on the new changes, hopefully work. Site is live. So if we now go to that link, we should be able to see it. Yes, it worked. So the thing about this is that this is something where you might want to have an immediate response. You don't want your friend to click the link like 1 second after you sent it, and then he just gets this 404 page. That's not a really great UI. So what this does, so if we create a new invite, let's see here. Let's just refresh it. And this time we send it to Steve. No, sorry, Wozniak. Hi, man. Want to join some foos? And we just keep standard colors. So what's going to happen now is that if we went to this link, you would expect a 404 page, right? But we're actually redirected. So what's happening here is that Netlify has this functionality where you can redirect if you hit upon a 404. So when I go to this link and Netlify sees that, oh, that's a 404, there's nothing here. I just redirected to this anonymous function, not anonymous function, serverless function, which then take this payload right here. So I just send that payload when I redirect. Takes that, goes to FaunaDB, retrieves the data dynamically, and then puts it in a template and returns that to us. So this works more like the traditional architecture, right? But now you have the option to actually have this immediacy if you need it, but also have the speed that static websites provide. So now that it's built, it's available normally. Yeah. So I think I have the time to also demo like a CMS thing. So let's do that. So there's the site built with GridSum, and this is Sanity, just the basic UI without any tinkering. So you can really customize this however you want. But this points to, let's try to find it. No, that's not it. Um, this is the URL. And let's go to the blog part. So this is that post that we just looked at, right? So the way the CMS works is we create some content. Hello, KDS. We click publish. This is then published. In the background, a webhook has been triggered. So if we refresh this page, we see that it started building. So I use GridSum here, and it's like the performance on GridSum is not the greatest. So we probably have to wait a little bit for it to compile. But the thing is, like content like this doesn't need immediacy. Like it could take some seconds before it becomes available most of the time. So it's like you could try to compare it to just cache being busted, right? So in a more normal scenario, you would have some cache that needs to be busted in order for people to see the new changes, and that always takes some time because you need to purge all the edges, right? So now the site is live, and if we go here and refresh our site, we should get hello KDS. Thank you, thank you. So yeah. So quick recap. What did we actually do? All we really did was we moved the template compilation from doing it at runtime to doing it during the build process, where thus like every single page is available at once. We don't have any runtime that needs to compile anything, and you can really decrease the load time it needs. The browser needs to retrieve the website. So some benefits that I didn't mention is like expenses. Hosting files is really cheap. Like both the examples that I showed you are built just on free tiers. Like I didn't pay anything except for the foosinvite.vip domain. That's the most expensive thing in that stack. Oh, I didn't mean to do that. Better performance. No need to build pages on the fly. And higher security, because you use microservice APIs, right? So the attack service is really reduced because you can't attack your entire technology stack. You just have this static website that just serves files, right? You can't attack that in any way. And the microservice APIs, like if you're using serverless functions, you're just writing code. You're not maintaining any architecture. So there's nothing to really attack there if the maintainers of that architecture are doing their jobs. And you can leverage domain expertise of third-party services, meaning that if you want some payment option on your site, you use Stripe, right? Because they have a really good API for doing payments. Auth0, if you want user authentication, they probably have done a better job than you could do yourself because they have a lot of people working on that specific domain. So, yeah, that's what I had to say. Thank you. Do we have any questions?
Yeah. How many times before have you had this talk? Oh, hello, you guys. How many times before
They held this talk?
This is the first time.
It's the first time.
Yeah.
Man, you need to get out there. This was a really great presentation, but I think I have some less flattering questions, or not less flattering, but it's also something about where you got your illustrations. But yeah, I was about to ask, is this more... I think you answered that. No, just flattery here. Yeah, great. Where do you get your illustrations?
I use a tool called Prezi,
Yeah.
P-R-E-Z-Y.
Yeah.
Which just has this built-in search for icons thing.
Oh, okay.
So I just search for icons.
Okay, so you use your presentation tool. Okay, right.
Yeah.
Yep.
Anything else?
Yeah, that was... Can anybody hear me? Yeah, okay. It was a super nice presentation. Thank you. I'm wondering, are there any types of web applications that you think, like in some fundamental way, can't be made jammy? Like, what kinds of applications couldn't be turned into a JAMstack? Or do you think that basically anything could be in principle?
Yeah, good question. So the thing is, since if you're using some like good JavaScript framework, you obviously also have the ability to use APIs, which then again it gives you you could just serve an HTML page that just contains your single page application, right, and pull every content from APIs. So I think everything could be solved by that, but obviously there's some, like the FOOS invite that I showed. Obviously you want the immediacy there, that the invite is available immediately, and if you don't want to do all this, that's its single purpose, and you don't want to do all this like trickery to get it to have two options. Like I needed to do make two ways of displaying the same page, right? So if you don't want that double thing, you could just use. It would be easier or perhaps faster to just use a more traditional approach, maybe. But I don't know. I really haven't thought that much about it.
Okay. No, but that sounds good. Thanks.
Every time we push code updates or every time we do a change publishing content, we will update the CDN. And I'm wondering if there are any issues with the invalidation, if it can end up going slow if we do updates too often. For instance, some organizations have out 100. Could this be an issue?
There's this case study, like Stack Magazine, this front-end magazine website. They use the JAMstack, and they have thousands or 10,000s of articles. And they also use the Git CMS approach, and that entails that their entire comment system, or every single comment, triggers a new build. So that's a lot of builds, right? So, and they make it work. So that means that I guess it would work.
So it scales in some manner within normal application at least.
Yeah, it seems like it scales. Yeah.
Yeah, that's great.
Yeah. Great. Thanks.